When you think about the cockpit of a modern jetliner, you've got one of the most experienced people on the planet, sitting right next to one of the most advanced computers ever made. It really makes you wonder, who's actually flying the plane? Let's dig in.
All right, to get to the bottom of this, let me ask you something. Picture it, you're cruising at 30,000 feet. What do you think is the single most important safety system on that aircraft? Is it the fancy flight computer, the navigation gear, all those backup engines?
Well, the answer might not be what you think. It's not a piece of technology at all. It's the humans sitting in the captain's chair, a sharp and, more importantly, a well-rested pilot. And understanding why that's the case, well, that reveals everything about the true partnership between people and machines up there in the sky.
See, a pilot's job isn't just about grabbing a joystick and steering. Their biggest fight, the one they're in for the whole flight, is against this invisible force called pilot workload.
Pilot workload is just that. It's the constant mental and physical drain of watching all the systems, navigating the plane, and just being ready for anything and everything. You can think of it like a battery. It's a limited resource, and it can definitely run down.
And when that mental battery gets low, things get serious. A pilot's awareness of what's happening around them starts to fade, their reaction times get slower, and that crucial margin of safety, it starts to shrink. This right here is the fundamental problem that so much of modern aviation technology is trying to solve.
And that, of course, is where automation comes in. But it's so important to think of these systems not as a replacement for the pilot, but more like the most dedicated, most tireless co-pilot you could ever imagine.
Now, this is a huge misconception that a lot of us have. We tend to think the autopilot is there to fly the plane better than a human can. But its real job is much simpler. It's there to handle all the boring, repetitive tasks. That way, it saves the pilots precious mental energy, keeping them fresh for the one moment they might be truly needed.
Of course, the machine has some incredible advantages. A human pilot can react in about 300 to 500 milliseconds. An autopilot? It reacts in just a few. So in that first critical second after something goes wrong, the machine has already started making corrections before the pilot's brain has even fully processed what's happening.
But what happens when it's more than just a little turbulence? What happens when you're faced with a situation that is so unique, so completely out of the blue, that there's simply no line of code written for it?
Let's just walk through a quick scenario. Imagine a giant Boeing 747, a 470-ton masterpiece of engineering, flying right over your head at 10,000 meters. And then, the unthinkable happens. Complete and total engine failure. All four engines just shut down. Absolute, eerie silence.
So what happens next? Does this huge metal bird just drop out of the air like a rock?
Not even close. You see, an airplane is basically just a very, very efficient glider. With no engine power at all, that 747 can glide for up to 150 kilometers. That gives the pilot a ton of time and a massive amount of distance to find a safe place to land. The plane is inherently stable, but, stability is one thing, making a life or death call is something else entirely. So let's jump from a hypothetical to a wild, true story that shows you exactly where a machine's programming ends and where human judgment absolutely has to take over.
The year is 1966. We're in Luxor, Egypt on September 30th. An Antonov aircraft, full of tourists, is barreling down the runway, picking up speed to take off for Cairo.
When all of a sudden, an obstacle appears. A 1-ton camel is wandering across the runway. The pilots have a split second to make an impossible choice. Hitting it would be catastrophic. Swerving off the runway means crashing into the desert sand. And hitting the brakes? Useless. They're going way too fast. So they made a decision that no computer could ever be programmed to make. They decided to try and take off. As one of the pilots said later, it was the only reasonable decision in a completely unreasonable situation. They pulled back on the controls, hoping against hope to clear the animal. They didn't quite make it. The nose gear slammed into the camel, completely destroying the landing gear. But they were airborne. So, with a busted plane, they flew all the way to Cairo, circled around to burn off their fuel, and then executed a flawless belly landing. The plane was a total loss, but thanks to that one creative, courageous, and completely unprogrammable human decision, every single person on board walked away without a serious injury. And that story, right there, it gets to the absolute heart of modern aviation safety. This isn't about human versus machine, it's about a perfectly designed partnership. It really just boils down to this. The machine is the master of routine. It cuts down on fatigue, and it reacts with inhuman speed. But the human is the master of the unexpected. They provide the judgment and the creativity you need in a crisis that has never happened before. So the whole system is designed for the automation to handle that 99.9% of the flight that is completely normal and predictable, and that frees up the pilot to be 100% rested, 100% alert, and 100% ready for that tiny 0.1% of the time when everything goes wrong in a way nobody could have possibly predicted.
Which leaves us with a pretty big final thought. In a world where our technology can handle almost everything, what is the true, irreplaceable value of human judgment? That's something to think about. Thanks for joining us.